Alright, hello everybody. In this video we're going to be talking about writing linear equations. Now the basic idea of writing linear equations is that we need to use the slope-intercept formula. There are multiple formulas out there such as standard form or point-slope form, but for this case we're just going to kind of focus mostly on the slope-intercept formula. So a couple different things we got to know about the slope-intercept formula is that M stands for slope and B stands for the y-intercept. There you go. Alright, so in our basic level, what we need to do in order to write a linear equation, we need those two things. Now, we're given all sorts of different formats of trying to put those together, and that's where kind of the different techniques come into play. Alright, so in these first couple of problems that I gave you, we have a graph of a line. Okay, so with this information, we need to figure out the slope and the y-intercept. Okay, with a graph of an equation, it's less difficult because we can use our either count or we can visually see where the y-intercept is, which really helps us out. So if we look at this first one here, we see that, and I could kind of draw down here. It's kind of a bad drawing though, and I'm going to try to guess that it probably crosses right here. So what I have here is a nice triangle. Now, slope stands for the change in y over change in x. Some people have also phrased it as rise over run. It's another key phrase. Or some people describe it more as rate of change. All right? The key part to make sure that you know is that y goes on top, so change in y. So if I count this one, what's the change in y? This is the y-axis, so I went 1, 2, 3, 4, 5, 6, 7. I went 7 down, and I went 2 over. So my slope for this particular number 1 is m equals 7 halves. All right? So I went down 7. I went down 7, negative 7 halves. And I went down 7, negative 7, and then over positive 2. All right? So now I have my slope written here, so I can fill that in. So I know that it's y equals negative 7 halves x. And like I said at the beginning, because it's graphed, I can easily see where it crosses the y-axis, so the y-intercept, and that would be positive 2. So my equation for this particular equation is, or my equation for this particular linear function is y equals negative halves x plus 2. Now you're probably asking, why is that so important? Well, I have a glimpse of just a small piece of this graph. What if I want to find out where it crosses at, or what it equals when it's negative 50? I can't see on this graph what it equals, but I can certainly just plug it into here and figure out what the point is at negative 50. All right, so this little snapshot gives me an idea of how it's going to go. Linear functions allow us to do this because of the fact that they are constants. This slope is going to be continuous, negative 7 over 2, negative 7 over 2, in both directions to infinity. All right, so let's look at this one now. If we look at, it looks like it crosses the x-axis here. Here's a point, here's a point, here's a point, and we go all the way to here. Okay, now I'm guessing this on because it looks like it crosses the point right there. All right, and so I do the same process. It goes rise over run. So I go 1, 2, 3. So it went up 3, and then it went over 2. So my slope is 3 halves. Now again, because it's graphed, I can easily see where it crosses the y-axis, which is at negative 2. So my equation of this line is y equals 3 halves x minus 2. Again, I could keep going on forever if I wanted to again. Let's see. 1, 2, 3, 1, 2. You'll notice I cross another line. So we could have, if I wanted to, say, oh, this is the first time it crosses something. I could go up and over, and I would get 6 over 4. You know, same thing, simplifies to 3 halves x, or 3 halves in this case. All right. Now, let's say, for example, we don't have a graph, but we do have points, which it's a very similar process, except we just don't have a coordinate plane to graph them on. Okay, so our first step we need to do is to find the slope between the 2 points. Now, there's a couple different ways to do this. You could use the slope formula, which is y2 minus y1 over x2 minus x1. Okay, that particular method I find sometimes gets a little bit crazy. So what I do is I just use this thing right here, change in y, change in x. I went from -4 to 2. What's the difference there? Well, it was a change in 6. -4 to 2. I gained 6, positive 6. What is a change from 0 to -4? Well, I went down 4. Okay? So that's the slope of this. And if you want to use the slope formula, perfectly fine, but I'm just saying that sometimes with the negatives and stuff, it can get kind of goofy. All right? So again, I'll try that again. I went from -4 to 2, which is +6. Then I went from 0 to -4, which is -4. Now let's simplify this a little bit. I'm just going to simplify this to -3/2. All right? So I know my slope is -3/2 x, but I do not have my y-intercept. Now comes the question of, well, what am I going to do? I have 3 different variables. I can't really just solve for b, but what you do have is you have a point that's on the line, all right? And so I could choose any one of these points. Actually, I'm going to choose this one just for difficult level, all right? So if I choose this point and I say, all right, this is going to be what I'm going to plug in here. This stands for the x. You could choose either one. So, and this stands for the y. So I have 2 equals -3/2 times -4 plus b. So we have 2 equals 12 over 2 plus b, or 2 equals, let's see, 2 plus b. All right, let's make sure my math is correct here. Let's see, we got -3/2. We put in -4, we got -12 or +12 over, that's where my problem is right there. That's a 2. Sorry. All right. So we have -3 times -4 is +12, and then that 2 just stays on the bottom if we multiply across. And so really what this should be is 6, right? And then if I subtract 6, I apologize for my work kind of flying off the table here. If I subtract 6, I would get -4 equals b. All right? So with that said, let's kind of put my work over here. All right? So with that said, what we're going to have here is y equals, I used my slope I had earlier, -3/2 x, and then I have my newfound y-intercept, which is -4. Okay? Now, let me go quickly back through that again. So what I did was I found the change in y over change in x, which came to -3/2. I then plugged that number into there, -3/2. I plugged -4 in for x, I plugged 2 in for y, and then I found what the y-intercept would be by solving for b, and then I just put it all together into one nice equation. All right? So on this next one, what I'm going to do is, let me find my eraser here. Nope, I erased the problem there. That's okay, you can rewind. Let me erase this little line here. All right, so let me get you started on this one. What I'd like you to do is you can pause the video right now and kind of try to work this problem and see if you get it right. But I'm going to try to work it rather quickly here. So I have the slope is from 2 to -7, or -5, which would be -7, and then I have 2 to 0, which would be -2, x plus b. All right. Now, what I have is negative over a negative, so that means that my slope is positive 7/2 x plus b. All right. So now what I'm going to do is I'm going to pick one of these points. I'm going to choose the easier one because it's 0 here. So I'm going to have plug my -5 in for y. I'm going to plug my 0 in for x. It's going to make the problem a lot easier. And you're going to see that -5 equals b, because 7/2 times 0 is 0. All right, so now I just need to write this all into one nice problem. So that would be y equals 7/2 x, because I already found the slope. And then my newfound y-intercept, which is -5. So hopefully this is the answer that you got. Linear equations are extremely important as far as setting the base for functions. And so it also helps us out in many of our math classes. So thank you very much for watching, and please come in if you have any questions.